In this lesson, we'll examine how to simplify powers of I. So remember that I is your basic imaginary unit, and it is defined as the square root of -1. So we know we just said that I is our basic unit. It's the square root of -1, but typically we're just going to leave it as an I. So let's evaluate what higher powers are. So I squared would be the square root of -1. Well, if I square that, I would be left with just the radicand. So this is -1. I cubed, well, that could be I squared times I by keeping your base and adding your exponents, which is the same as -1 times I. So this is -I. I to the fourth, several ways to think this one through. This could be I squared times I squared. And we know that I squared is -1. So -1 times -1 is +1. All right? So you're going to focus on these four values, and frankly, I would memorize these four. I'm going to continue and look for a pattern beginning with I to the fifth. So I always love to start with I to the fourth since I know that that's 1. So if I take I to the fourth times I, times, not equals, that's the same as 1 times I, which is just I. I to the sixth would be I to the fourth times I to the second by keep your base and add your exponents. So that's going to be 1 times -1, which is -1. I to the seventh would be I to the fourth times I to the third, which is again 1 times -I, which is just -I. I to the eighth would be I to the fourth times I to the fourth, which is 1 times 1, which is 1. So hopefully you see what's highlighted is these four values are going to repeat over and over. So since these four values repeat, every higher power of I can be re-expressed as one of these lower values. So what you can do is, if you have a higher power of I, just take the exponent and divide it by 4. If it goes in evenly, it's going to be 1. If the remainder is, if it has a remainder of 1, it's going to be I. A remainder of 2, it's going to be to the negative, or it's going to be -1, and a remainder of 3 would be -I, whereas I just said a remainder of 0 would be exactly 1. Let's illustrate what I'm talking about with an example. So what I do is I take my exponent of 27 and I see how many times does 4 go in there. It goes in evenly 6 times, and I would have 3 left over. So since the remainder is 3, from my pattern, I know that this has to be -I. Now, an alternate way of thinking this through is to write it out with your exponent rules, which honestly, I think I prefer this alternate way. I to the 27th, well, I first start by writing it as I to the 4th, because I know that's 1. That can be raised to the 6th power. Well, that would be I to the 24th. So what do I have left over? I have I to the 3rd. So I to the 27th is equal to this expression. Why is that helpful? Well, I look at this first part. If I have 1 raised to any power, it's always going to be 1. And if I have my pattern memorized, I to the 3rd is -I. So my final answer is -I. You can choose which method you like best. I to the 361st. If I take this and I divide it by 4, I get that it goes in 90 times, and I would have a remainder of 1. So a remainder of 1 is going to be I. An alternate way would be to write this as I to the 4th, which I know is 1, raised to the 90th. 4 times 90 is 360, which means I need 1 more power of I to the 1st. This would be 1 times I, which is equal to I. For this one, pause the video and you try it. I get a remainder of 0, which means it's going to go in equally, so it's going to equal exactly 1. An alternate way to show your algebraic work is again I to the 4th, because that's 1, raised to the 39th power. Well, 4 times 39 is exactly 156, so this is 1 raised to the 39th, which is just 1. The second thing I'd like to do is remind you how to simplify square roots with negative radicands. So to simplify the square root of negative 81, this could be expressed as negative 1 times 81 in the radicand. And we know the square root of negative 1 is defined as I, and the square root of 81 is 9. So this is best expressed as 9I. Now, when you have one like the square root of negative 72, what I like to do is think about my perfect squares and find a perfect square that goes into 72. So this could be equal to negative 1 times, well, I know that 36 goes into 72, and it goes in 2 times. So I can express this as so, and I know that the square root of negative 1 is I, the square root of 36 is 6, and the square root of 2 is irrational, I don't know it, so this is best written as 6I times the square root of 2. I want to point out that sometimes you will also see it written as 6 square root 2 times I, but you need to make sure that I is not under the radical sign. Pause the video and try this one on your own. So I broke the radicand up into negative 1 times 64 times 3. 64 is a perfect square, and I know the square root of negative 1. So the square root of negative 1, this is I, so I'd have 5 times I. Square root of 64 is 8, and the square root of 3 is irrational. I don't know that, so that stays under the radical sign. So I'm just going to multiply my coefficients here together, so I would have 40I times the square root of 3. Your alternate way of writing that is 40 square root 3 times I, but again, make sure your I is not underneath the radical sign. If you still have questions on this concept, I suggest you rewatch the video, look for other resources online, or of course, email your facilitator for additional help.